Alright, let's go. Number 10. The 16 molecules in the sniff. Fred Ghostman and his team at the Max Planck Institute for Solar System Research in Göttingen spent over a decade building an instrument called COSAC for one specific job. Drill into a comet, heat the powder in a small oven, push the vapor through a gas chromatograph and a mass spectrometer. A tidy, mundane laboratory procedure performed 500 million kilometers from the nearest laboratory. The standard picture of a comet nucleus is chemically simple. Water ice, carbon monoxide, carbon dioxide, methane, silicate dust, and a smear of carbon compounds no more complicated than formaldehyde. The elaborate carbon chemistry that eventually becomes biology is supposed to happen later, somewhere warm, somewhere wet, on a planet with liquid water and several 100 million years to spare. Philae bounced. The drill never properly engaged. Ghostman's team fell back on an emergency setting called sniffing mode, which passively draws whatever drifts into a vent pipe. 25 minutes after first touchdown, a spectrum came back. It was not simple. Ghostman and colleagues in Science, Volume 349, Article ABE 0689, published on the 31st of July 2015, reported 16 distinct organic compounds spanning 6 chemical classes: alcohols, carbonyls, amines, nitriles, amides, isocyanates. 4 had never been reported at any comet in history: methyl isocyanate, acetone, propionaldehyde, and acetamide. The suite was heavy in nitrogen-bearing species. It contained no sulfur-bearing species at all. Contamination from the lander itself was checked against blank spectra taken before arrival. Clean contamination from Rosetta's thrusters was ruled out on timing. Synthesis inside the coma after release was proposed, but the relative abundances do not match a coma-produced distribution. Radiation processing of the outer crust was proposed, except the bounce had exposed shielded subsurface material, and the missing sulfur has no accepted explanation whatsoever. Sulfur is abundant at 67p. Rosina measured hydrogen sulfide in quantity. COSAC saw none of it. Acetamide contains the amide bond. That is the exact chemical linkage joining every amino acid to the next one in every protein currently holding your body together. It was sitting in a 4.5 billion-year-old ice ball. If the bond that builds you was already assembled before Earth existed, what precisely did Earth contribute? The chemistry was strange. The ground it sat on was stranger. Number 9. The collapsing ground. Jean-Baptiste Vincent, also at the Max Planck Institute in Göttingen, was doing surface cataloging. Routine geomorphology, counting circular features in OSIRIS camera images to estimate how old and how eroded the surface was. Crater counting is the least glamorous job in planetary science. Somebody has to do it. On an airless body with no atmosphere and no weather, circular depressions mean impacts. Impact craters carry a signature you can check against: a raised rim of ejected material, a shallow bowl profile, a debris apron, and a depth-to-diameter ratio somewhere near 1:5. The pits were not craters. The walls were vertical. There were no rims. Depth to diameter ran close to 1:1. And gas was streaming out of the bottom of several of them. Vincent and colleagues in Nature, Volume 523, pages 63 to 66, published on the 2nd of July 2015, cataloged 18 quasi-circular, straight-sided pits, all of them in the northern hemisphere, ranging from 10 meters to hundreds of meters across, and at least 100 to 200 meters deep. The most active, labeled Seth_01, measures 220 meters wide and 185 meters deep. Impact origin fails on geometry, on the absent rims, and on the clustered spatial distribution. Excavation by a single violent outburst fails because outbursts of that energy leave ejecta blankets, and there are none. Top-down sublimation fails because that carves shallow bowls, not vertical shafts. What survives is sinkhole collapse. A cavity forms underground, the ceiling thins until it cannot carry its own weight, and the roof falls in, which requires that the interior of this comet is hollow in places. Nothing in any formation model tells us what excavates the cavities. This is a body 4 kilometers long, with voids hundreds of meters wide inside it. If you stood on the surface, the ground under your boots would be a ceiling over an emptiness you could not see, measure, or anticipate. What is carving the caves? The pits do not merely sit there. They fire. Number 8. The summer fireworks. Vincent again, this time working with Michael Ahern at the University of Maryland, and on monitoring duty rather than analysis. Rosetta was approaching perihelion in August 2015, and the cameras were simply running, taking routine images to track dust density around the spacecraft. Housekeeping. Collision avoidance. Cometary activity is supposed to be a thermal function. Sunlight goes in, sublimation comes out. Warm a patch of surface, and gas leaves it. Rotate that patch into shadow, and the activity falls away. Smooth, predictable, governed almost entirely by illumination angle and local noon. 34 discrete explosions in 3 months, one every 2.4 rotations of the nucleus. Some fired at dawn. Some fired shortly after local noon. Several came from the same locations at incompatible times of day. Vincent, Ahern, Lynn, Elmary, Pohola, and 50 other authors. In monthly notices of the Royal Astronomical Society, Volume 462, Supplement 1, pages S184 to S194, published in 2016. 3 distinct plume morphologies: a narrow jet, a broad fan, and composite structures containing both. Almost every source sat in the southern hemisphere, clustered along regional boundaries marked by steep scarps and cliffs. Simple diurnal heating fails, because the same patch erupts at 2 incompatible local times. Rotational stress and centrifugal shedding fails, because the outburst sites show no correlation with the areas of maximum centrifugal force. Amorphous water ice converting to crystalline ice and releasing trapped gas works energetically, but demands compositional patchiness on scales below 100 meters, which no formation model produces. Cliff collapse has been directly photographed by Pohola's team for at least one event, and cannot account for the dawn events at all. This is a mountain-sized object that detonates on no schedule. Rosetta was struck by debris and lost star tracker lock. A crewed vehicle in that position would not have come home. If the trigger is buried, how would you ever see one coming? The explosions were loud. What the magnetometer picked up was quieter. Number 7. The Song. Karl-Heinz Glasmayer at the Technische Universität Braunschweig was running the RPC magnetometer for an entirely ordinary reason. He wanted to know whether the nucleus of 67P carries an intrinsic magnetic field. It is a standard measurement. Arrive, establish a baseline, subtract the solar wind, publish the number. Comet nuclei are not expected to have magnetic fields of their own. What the instrument should have recorded is the draped interplanetary field, smooth, slowly varying, carrying whatever turbulence the solar wind happens to impose. Nothing organized, nothing periodic. From the 6th of August 2014, the day Rosetta arrived, the magnetometer recorded large amplitude, quasi-coherent oscillations. Regular, structured, the field around the comet was ringing. Ingo Richter, Glasmayer, and colleagues published the analysis in Annales Geophysicae in August 2015. Roughly 3,000 wave events over 4 months. Frequency between 40 and 50 millihertz, meaning one complete cycle every 20 to 25 seconds. Amplitude comparable to the background field itself, with delta B over B approaching 1. Still detectable when the comet was 350 million kilometers from the Sun. The classical cometary wave modes fail. Those appear close to the Sun in dense plasma at different frequencies. Ion cyclotron waves fail on frequency for the local field strength. Instrumental artifact was tested across all 3 magnetic components independently and eliminated. Spacecraft interference was eliminated. Richter's team proposed a cross-field current instability driven by freshly ionized cometary water molecules. It reproduces the frequency. It does not fully reproduce the amplitude, and it does not explain why the waves are so coherent. A 4-kilometer lump of ice with no core, no dynamo, and no field of its own spontaneously organized its surroundings into a single sustained tone. Shift the pitch up by a factor of 10,000, and a human ear hears it as music. How does an object with no clock keep time? Some comets hum. One of them detonated. Number 6. The Holmes Event. In October 2007, Comet 17P Holmes was professionally uninteresting. A Jupiter family comet with a 6.9-year orbit, a nucleus about 1.6 kilometers in radius, no notable activity on record since the 19th century, and almost no observing time allocated to it. The amateur astronomer J.A. Henriquez Santana was looking at it casually. Comet brightness tracks distance from the Sun. Holmes had passed perihelion 5.5 months earlier and was receding, sitting at 2.44 astronomical units. It should have been dimming steadily toward invisibility. In roughly 42 hours, it went from visual magnitude 17 to magnitude 2.5, a brightening factor of about 1 million. It became a naked eye object, and its expanding dust cloud grew in angular size until it was larger on the sky than the Sun. Documented across dozens of papers, including Zdenk Sekanina's analysis and the study by Lee and colleagues in the Astronomical Journal, Volume 138, 2009, 1 to 2% of the entire nucleus was ejected. The coma expanded at roughly 550 meters per second, and Holmes had done exactly this before, in November 1892, and again in January 1893. Same interval after perihelion, 115 years apart. Impact by another body fails on the recurrence. The same rock does not strike twice with a century between. A pressurized gas pocket rupturing cannot supply enough energy to shed 2% of a nucleus. Amorphous ice crystallization is energetically plausible, but the trigger depth and timing have never been successfully modeled. Rettig and colleagues in the Astrophysical Journal in 1992 proposed hydrogen cyanide polymerization. Richard Miles in 2007 proposed radiation-produced hydrogen peroxide accumulating in subsurface voids and then decomposing catalytically on iron-bearing minerals. Neither has been tested in a laboratory. Nucleus splitting was searched for and no persistent fragments were found. A quiet, catalogued, thoroughly unremarkable object threw off a 50th of itself in under 2 days, and nobody has established why. We currently track thousands of objects on the assumption that they behave. Which of the ones we have marked harmless is simply waiting? Holmes survived its own violence. Others do not. Number 5. The String of Pearls. Carolyn Shoemaker, Eugene Shoemaker, and David Levy were running a routine near-Earth object patrol at Palomar Observatory with a 46-centimeter Schmidt telescope. Photographic survey work, night after night. The plate they exposed on the 23rd of March 1993 had been partially light damaged and was very nearly discarded as unusable. A comet is a discrete object. It sublimates, it erodes, it decays across thousands of orbits. Catastrophic disruption should be rare, and when it happens, it should be messy. A smeared, diffuse cloud, not a structure. They found roughly a dozen separate active nuclei arranged in a straight line. As the fragments drifted apart over the following months, the count rose to 21. Beads on a wire. Zdenk Sekanina, Paul Chodas, and Donald Yeomans at the Jet Propulsion Laboratory reconstructed the orbit in Astronomy and Astrophysics, Volume 289, in 1994. The breakup occurred on the 7th of July 1992 when the comet passed roughly 40,000 kilometers above Jupiter's cloud tops, deep inside the Roche limit and inside the orbit of the moon Métis. Progenitor radius, approximately 5 kilometers. Mass around 10 to the power of 17 grams. The fragments struck Jupiter between the 16th and 22nd of July 1994. A cohesive, rock-like nucleus fails. A solid body of that size and strength would have survived those tidal stresses intact. A completely strengthless rubble pile fails in the other direction. It would have sheared into a continuous stream rather than 21 discrete lumps of comparable size. Sekanina later argued the original tidal split produced only 10 to 12 major fragments, with the remainder appearing afterwards through secondary breakup that had no external trigger at all. 30 years on, the internal strength of comet nuclei remains genuinely unsettled. Jupiter's tides took a 5-kilometer object apart in under 2 hours. The impact scars left in Jupiter's atmosphere were wider than Earth, and they were visible for months. If we still cannot agree how strong a comet is, what exactly is any deflection plan built on? That comet was dry rubble. Some of them appear to have been wet. Number 4. The wet interior. Eve Berger, then a graduate student at the University of Arizona, was working with Thomas Zega, Lindsay Keller, and Dante Loretta on mineralogy of stardust grains, dust captured from Comet 81P/Wild 2 and returned to Earth in 2006. The assignment was sulfide identification, electron microscopy, and X-ray analysis. Inventory work. Comets formed far beyond the water snow line and have never been warm. Their interiors sit at tens of Kelvin. Liquid water requires a combination of temperature and pressure that a body a few kilometers across, made of ice, has no mechanism to generate. The grains contained cubonite. The low-temperature orthorhombic form of cubonite only crystallizes in the presence of liquid water. Berger, Zega, Keller, and Loretta, in Geochimica et Cosmochimica Acta, Volume 75, pages 3501 to 3513, published in 2011. The orthorhombic cubonite constrains formation to below 210 degrees Celsius. The accompanying pyrrhotite is the 4C monoclinic polytype, unstable above roughly 250 degrees. Pyrrhotite pentlandite assemblages push the ceiling lower still, into the range of about 100 to 135 degrees. Terrestrial contamination in the aerogel collector fails. The assemblages match hydrothermally altered CI chondrites, not any laboratory material. Capture heating fails in the wrong direction. Aerogel capture briefly heats grains to thousands of degrees, which destroys these phases rather than forming them. Inward to outward transport from the warm inner solar system could explain cubonite alone, but not the coexisting low-temperature assemblages sitting beside it. What remains is aqueous alteration inside the comet. Something melted pockets of ice within the nucleus. Impact heating has been proposed. Radioactive decay of aluminium-26 has been proposed. Neither has been demonstrated for a body this small. Liquid water, warmed minerals, and organic molecules inside the same object at the same time. That is not a delivery vehicle. That is a reaction vessel. How long did the water last, and what happened in it? Everything so far formed around our own sun. The next one did not. Number 3. The visitor's chemistry. Dennis Bodowitz at Auburn University, and separately Martin Cordner and Stephanie Millam at NASA Goddard, were doing straightforward composition work on 2I Borisov, the first notably active interstellar comet discovered in 2019. Measure the volatiles. Compare against solar system comets. Publish the comparison table. Planet formation is assumed to follow universal physics, and chemistry is the same everywhere. A comet from another star should broadly resemble a comet from ours. Inside 2.5 astronomical units, water dominates, and carbon monoxide is a minor component, typically a few % of the water abundance. Borisov's coma contained more carbon monoxide than water. Bodowitz and colleagues, in Nature Astronomy in 2020, reported a CO to water abundance of at least 173%, more than 3 times higher than any comet ever measured in the inner solar system. Their Swift and Hubble observations across December 2019 and January 2020 gave a range of 130 to 155%. Cordner and colleagues, in the same journal, using ALMA on the 15th and 16th of December 2019, measured a carbon monoxide production rate of 4.4 times 10 to the power of 26 molecules per second. Solar system comets inside 2.5 astronomical units run between 0.2 and 23%, and typically sit around 4. Observational error fails. 2 independent teams, 2 independent facilities, ultraviolet and millimeter wavelengths in agreement. Transient outburst enrichment fails, the ratio held across weeks of observation. A hidden carbon monoxide reservoir that we have somehow missed in our own comets fails against decades of measurements. What survives is that Borisov formed somewhere genuinely unlike here, beyond a carbon monoxide ice line, possibly around an M dwarf, possibly as a fragment of a shattered exoplanet. One object, from one other star, and the chemistry was already wrong. We have a sample size of one solar system, and we have been generalizing from it for 400 years. If the first foreign comet broke the pattern, was there ever a pattern? Borisov brought carbon monoxide. Our own comets brought something harder to look at. Number 2, the amino acid in the cloud. Catherine Altweg at the University of Bern led Rosina, a mass spectrometer whose headline assignment was isotopic bookkeeping. Measure the deuterium content of cometary water. Settle, or at least constrain, the long argument about where Earth's oceans came from. Accounting, essentially, with a very expensive calculator. Amino acids are the units from which proteins are assembled. More than 140 molecular species have been identified in the interstellar medium, and not one of them is an amino acid. The standard view holds that amino acids require aqueous processing on a parent body, meteorite chemistry, not free cometary gas. On the 28th of March 2015, during a close flyby between 14 and 26 kilometers from the nucleus, Rosina detected glycine in the coma, not in a returned sample. In the gas. Altweg and colleagues in Science Advances, Volume 2, Article E1600285, published on the 27th of May 2016. Glycine detected alongside methylamine and ethylamine, its two chemical precursors. Highest measured glycine to water ratio, 1/6 × 10 to the power of -3. First detection in October 2014, with most measurements taken around perihelion in August 2015. And in the same dataset, phosphorus, the backbone element of Dina and Rina, detected at a comet for the first time. Spacecraft contamination fails, pre-arrival measurements verified there was no terrestrial glycine source on board. An instrumental artifact at mass 75 fails, because the precursor masses 30, 31, and 45 appear in the correct proportions alongside it. Direct sublimation from the nucleus fails, the density profile with distance is wrong for a point source. What remains is that the glycine is released from dust grains warming in the coma, which means it was locked inside the solid material, which means it predates the comet. Glycine, methylamine, ethylamine, and phosphorus in one object, essentially unchanged since before the planets finished forming. The parts list for a living thing, on ice, older than the ground you were standing on. If the parts were already made out there, was Earth ever the origin of anything? Which leaves the question the whole field has been circling for 50 years. Number 1. The delivery. Christopher Chiba, then working with Carl Sagan at Cornell, set out to do a budget. Tally every plausible source of prebiotic organic molecules on the early Earth. Lightning, ultraviolet light, atmospheric shocks, impact synthesis, and delivery from space, and rank them against each other. A bookkeeping exercise intended to close the question rather than open it. The Miller-Urey consensus held that Earth manufactured its own organic inventory, in its own atmosphere and its own oceans. Delivery from space was a fringe position, associated publicly with Fred Hoyle and Chandra Wickramasinghe, and treated accordingly by the field. The columns came out level. Across a wide range of plausible early atmospheres, the heavy bombardment either delivered or generated as much organic material as every terrestrial source combined. Chiba and Sagan, in Nature, Volume 355, pages 125 to 132, published on the 9th of January 1992. Their earlier work with Paul Thomas and Lee Brookshaw, in Science, Volume 249, 1990, had already shown that comet impacts can deposit intact organic molecules without pyrolyzing them, given shallow entry angles and atmospheric braking. Life appears in the rock record around 3.5 billion years ago. The heavy bombardment ends around 3.8. The delivery is negligible objection died with the inventory. The nothing survives impact objection died with the 1990 modeling. But the Comets brought our water version has a hard problem of its own. Altweg's Rosina team, in Science, Volume 347, 2015, measured 67 P's deuterium to hydrogen ratio at 5.3 times 10 to the power of -4, roughly 3 times the value in Earth's oceans. Comets like 67P did not fill the seas. And yet Herschel found that 103P/Hartley 2 matches Earth almost exactly. The population is not uniform, and no formation model explains the spread. The strong version, that living cells rodent intact, remains unevidenced and probably untestable. The weak version is now mainstream. The molecules that became you may have been assembled in interstellar ice and dropped here by objects that were not going anywhere in particular. If the recipe arrived already written, where was it written, and in what? Every entry on this list came out of someone doing routine work, cataloging sulfides, counting craters, measuring an isotope ratio to settle an old argument. None of them went looking for the thing they found. The universe is not confused about any of this. It has been doing it consistently for 4.5 billion years, without commentary. We are the ones improvising. Comets are not visitors to our story. We may be a footnote in theirs. If you want to see more videos like this, click the video on screen now.